let's get started on deploying the StreamNative BYOC Ursa cluster that's also going to stream data into an S3 table bucket. In addition to the S3 table bucket, I have created a general purpose bucket to use as the backend for this cluster. You have the option to either have a user-generated bucket, or you can use the one provided by default in the StreamNative cloud environment. In a separate video before this one is when I've shown the directions on creating that S3 table bucket, the user-provided general purpose bucket, and making sure all the permissions are set up correctly. So here I'm going to click on plus new to deploy my new StreamNative BYOC Ursa cluster. And we're going to be using the BYOC option. So of course I've already run the vendor access module as well as created the cloud connection and the cloud environment, so we're ready to deploy the BYOC cluster. I'm going to give the cluster a name, select my cloud connection and select Ursa engine. Under cluster location, I'll give the cluster a name. Make sure to select the correct cloud environment. This cloud environment is in the same region as the user-provided bucket I'm going to use, and also the same region as my S3 table bucket. And then I'll finally go to Lakehouse storage configuration. I do want to use my own bucket for this demonstration since it's slightly more complex. And here I filled in the AWS role ARN. This was created using a Terraform module that's specifically only needed when you're going to use your own bucket and the S3 table bucket. The region, the bucket name that I created for the backend of the cluster, again, this is a general purpose bucket. And then I created a folder inside of that bucket called test. And I had run the Terraform module to create the permissions for this bucket in the previous video. Next, I'm going to enable catalog integration. For S3 table, we only currently support external table, and I'm going to select the AWS 3 table. And then for my warehouse, this is the ARN of the S3 table bucket. And for the endpoint here, I have to make sure that I'm using the correct region. Here it's US East 2. Next, I go on to the cluster sizing, but it's actually going to do a pre-flight check of security here to make sure I have access into the general purpose bucket that I'm using for the backend storage of the cluster if you chose that option. And it's also checking if I have access into the S3 table bucket. This looks like it passed okay. So here on the cluster sizing, I'm just going to go and I'm going to leave this as it is with the smallest cluster size, and I'm going to click finish to start deploying my cluster. Heading back to the organization dashboard, we can see that our BYOC Ursa cluster is now up and running with the green filled circle. If I go ahead and click on it, this brings us to the cluster dashboard page. Before we start publishing messages to it, I just want to show you under the configuration page, you can see the configuration of your Lakehouse storage here. And if I go back to the cluster dashboard page and click on overview, we'll be able to get our endpoints. Here's our Kafka service URL and our schema registry URL endpoints. I'm going to go ahead and copy those out and put those into some Kafka code I have in IntelliJ, and we'll start testing out this cluster. Here in my client.properties file, I've updated my Bootstrap server here to have the endpoint of the cluster we were just looking at, as well as the endpoint for the schema registry. And then I'm going to be publishing messages to Kafka topic 1. Let me go ahead and start up my producer here. It has 10 million messages that are of Avro schema type. So let me go ahead and right click on that and say run the producer, and we'll start publishing those messages. I've gone back into S3 in my general purpose buckets in my StreamNative custom bucket 3 that I configured for the backend of the cluster. Remember, we had created a test folder in here. You can now see that the cluster has created a storage folder, and this is where the data is initially stored in Ursa format. However, the cluster should also be writing the data over into our S3 table bucket. So let me go to my table buckets here. And if I click on my bucket 3 that we've configured for this server, we can now see that there's an entry for a table called Kafka topic 1, which corresponds to the topic that we're publishing to. It's inside of a namespace, and this is a table bucket namespace that's the words pulsar underscore concatenated with the tenant and namespace that we're publishing to in StreamNative into our Ursa cluster. Now, because I was publishing to Kafka topic 1, for Kafka, that by default goes into the public tenant and the default namespace of Pulsar, which is why the namespace here shows us Pulsar underscore public underscore default. So if you had different tenants and namespaces you were publishing to, you would see different entries here. It's going to be important because in the next video, we're going to configure lake formation. And part of that configuration is mapping these namespaces. But for now, that's all I wanted to show you here in Amazon S3 in the general purpose bucket and your special S3 table bucket.